Most theoretical physicists and mathematicians operate under a quiet, almost unquestioned assumption. They believe mathematics exists independently of the physical universe. This is mathematical Platonism. It posits that numbers, geometric shapes, and constants reside in an eternal, transcendent realm beyond spacetime. Platonists view these concepts as discoveries waiting to be found. The Nobel laureate Roger Penrose is a prominent modern defender of this transcendent mathematical view. He structures a three-world ontology. The physical universe, human consciousness, and a timeless mathematical domain exist as distinct, interacting spheres. Here, the human mind accesses mathematical truths, applying those abstractions to make sense of physical phenomena. This introduces a mechanical problem known as the metaphysical gap. There is no biological mechanism explaining how a physical brain can causally interact with an immaterial realm that exists outside of space and time. Empirical science relies on observable causal mechanisms. The Platonic model requires an unobservable metaphysical leap, characterizing it as a scientifically unsupportable illusion. We can find mathematical structure without relying on an abstract void. The actual origin point is the churning, physical universe itself. This follows an alternative framework called Stoic Corporealism. At its core is the concept of logos, the active, rational structure embedded directly within the cosmos. The Stoics operated on a strict materialist axiom: only bodies with causal power truly exist. They rejected the idea of secondary realms housing perfect forms. Under this framework, mathematics is an incorporeal relation. It is a conceptual tool used to describe patterns, but it has no independent existence outside the mind. Mathematics functions as an emergent syntax that adapts to describe how matter behaves. It does not dictate laws from above. What we record as universal mathematical laws are human abstractions. They are the deep structural regularities generated by physical objects, distilled into a language we can process. Stoicism anchors our equations entirely in immanent, observable reality. It pulls the foundation of mathematics away from the supernatural. Every piece of mathematical reasoning begins with a biological organism observing its environment. Our cognitive starting point is the direct sensory observation of discrete physical objects. Early humans derived the concept of two through the physical act of counting tangible items. They did not retrieve it from a heavenly realm. The concept of number functions as a relational marker. It allows us to encode the material multiplicity we encounter in nature. The same rule applies to geometry. Consider the abstract concept of a perfect circle. We formulate this shape by observing recurring natural phenomena, like the concentric ripples expanding across water, and idealizing the pattern. The geometric spiral is often viewed as a transcendent truth written into the fabric of the universe. Yet the mathematical spiral maps directly to the evolutionary and physical constraints of biological growth, like the expanding internal chambers of a shell. Foundational mathematical concepts are generated through our direct sensory engagement with the corporeal cosmos. Platonism relies on an aesthetic belief that abstract forms are perfect, while physical reality is inherently flawed and messy. From a Stoic perspective, this hierarchy is an ironic reversal of reality. A mathematical spiral functions as a simplified approximation of a complex physical territory. It is a stripped-down version of the original. To function cleanly on a chalkboard, the abstraction omits massive amounts of physical data. It deletes surface tension, microscopic irregularities, and gravitational distortions. Universal constants like pi are stable ratios that reliably emerge whenever physical matter forms circular patterns. They are not transcendent dictations from beyond. The so-called perfection of a mathematical abstraction is actually a severe loss of physical detail. The messy, material cosmos is the true, richer source of rational order. This brings us to the principle of contextual meaning. If you remove material systems from the universe, mathematical laws lose all meaning and function. Take Isaac Newton and his law of universal gravitation, long considered a universal mathematical truth. This equation inherently requires the existence of actual physical masses interacting across physical space to hold any significance. If you strip away the physical bodies from the scenario, the mathematical concept of gravitational attraction becomes completely absurd. We require a rigorous syntax to encode these physical causal relationships. Historically, this was pioneered through Stoic propositional logic. Aristotle focused on grouping classes of objects. The Stoics built a far more dynamic system. They focused on the operators, the conditional statements like if-then, that bind distinct physical events into predictable causal chains. This propositional syntax shows how mathematics operates as a highly adaptive language designed to map structural patterns of matter. It is not a divine decree. By the 20th century, this language had become so successful that a pervasive, almost mystical belief took hold among physicists regarding its predictive power. The physicist Eugene Wigner formalized this awe in an essay, marveling at what he called the unreasonable effectiveness of mathematics in the natural sciences. This effectiveness is the result of centuries of relentless empirical tuning. It is an inevitable outcome. We are looking at a case of survivorship bias. Science naturally discards thousands of failed equations, preserving only the models that successfully map onto the physical world. We see this iterative refinement in the shift from Newtonian physics to Albert Einstein's general relativity, a transition forced by observed anomalies like the precession of Mercury's orbit. Einstein adapted our propositional syntax to account for newly observed extremes of mass and light. He did not access a new Platonic heaven. Mathematics appears matched to the universe because humans have spent centuries iteratively sculpting it to fit the causal regularities of the logos. Today, the computational era and big data have massively accelerated this process of empirical tuning and adaptation. The rational structure of the cosmos is too deep for one system to contain. We should view mathematics as an infinite game rather than a static list of edicts. As we probe deeper into extreme complexities, like quantum indeterminacy or chaotic climate systems, our mathematical syntax is forced to continuously branch and evolve. The future of discovery is a collaborative feedback loop between human observers, machine learning algorithms, and the physical environment. We rigorously cultivate mathematics from the material world. It is not discovered in an immaterial void, nor invented arbitrarily. It stands as a living dialogue, a propositional syntax through which we participate in the organized logic of the universe.